Hey everyone, in this video we are going to solve the classic 01 knapsack problem using dynamic programming. Let's first understand what the problem is, then we'll dry run through an example, and then finally see the code implementation. So the problem statement says, consider yourself as a thief. You are supposed to steal some items, but the bag that you carried with you had a limited capacity. That means you can only carry certain number of items. Now, since you are a thief, your target should be to get maximum profit. Now, each item has its own weight and value, and your knapsack or the bag that you are carrying has a certain weight. For each item that you pick, since it's a 01 knapsack problem, you will either pick the whole item or you won't pick it. That is how it got its name, like 01 version. Either include the item or exclude it. There is no partial picking allowed. So the problem statement is, suppose you have a knapsack and there are n given items to choose from. Each of these n items have a value associated with them and a weight. So this value array is the value of each of those items. That means this is I1, I2, I3, I4. And same for the weight. This is the weight of item 1, item 2, item 3, and item 4. And 8 is the maximum value of your knapsack. So your knapsack can only carry items that sum up to weight 8. So how are you going to solve it? Let's first see what dynamic programming is and when do you use dynamic programming. So there are two patterns that you can observe. If you see them in a problem statement, that means you're supposed to go for dynamic programming approach. The first one is optimal substructure and the other one is overlapping subproblems. Now, what do these terms mean? Optimal substructure refers that out of this array of items, you need to find certain subset, like let's say item 1 or item 3, or this is one subset. There can be many subsets like item 1, item 2, item 1, item 3, item 2, item 4. So there are various combinations for these items that you can choose. But you are supposed to choose such a subset that can give you a maximum value and in a way that it should not exceed the weight of your knapsack. This is implied by optimal substructure. Overlapping subproblem means now for each of these subsets, you need to check that do these two conditions satisfy? That means is the weight of your knapsack in check or not? Is the combination of items? That means if you take I3 and I4, this will supersede whatever is the weight because weight is 4 and 5, which is 9, which is more than 8. So how do you come up with the solution? Let's build the solution. Now for building a solution to every problem, the first thing that you need is a base case. Starting with base case. Now the maximum weight of my knapsack is 8. So I will be building my knapsack table up to weight 8. Now all these columns are my sub knapsacks. That means I am building for each of these columns. When you start building the knapsack 01 knapsack problem, you start with a 2D array. This 2D array is n, that means number of items cross your maximum weight. As you have already seen, I have written the number of items. I have 4 items, 1, 2, 3, 4. Corresponding to each of them has these values and these weights. Now these values, that means your 0, 1, 2, 3, 4, 5, 6, 7, 8, these are the weights of the knapsack. And you need to find the maximum value that can fill up to the 8 kg of the knapsack. So the base case is, if I am at this place, my knapsack size is 0. These all are knapsack sizes. If my knapsack size is 0, that means I can get, what value can I get? I can only get 0 value. Because if I don't add any item to my knapsack, there won't be any value generated for it. Same for if you add 0 item. Irrespective of the size of the knapsack, you will get value 0 because you haven't added any item. This is the base case. So base case implies that when your item is 0, the value is 0. When your knapsack size is 0, the value is 0. Now how do you fill? Now each of these cells will have a certain value. Let's move forward. When we move forward to item 1, what is the weight of the item 1? Now weight of item 1 is 3. That means I can only add this item when my knapsack size becomes 3. My knapsack size becomes 3 at this point. So for item 1, I can get a value of 4 when my knapsack size becomes 3. Now until my knapsack size becomes 3, since I only have considering item 1, I can't add anything to it. So that means this will remain as 0. Now moving forward, if my knapsack size becomes 4, still my item weighs 3 and I'm only considering one item. So the value that can be generated is 4 and so on. Now moving forward to next item. That is my item 2. Now for my item 2, the weight is supposed to be 2 in order to get the value 3. So when does my knapsack weight becomes 2? It becomes when I iterate to this 2. So I'll update the value for this to 3. Now while updating this to 3, I have to compare it to the previous one. Is this more than my previous one? Because at the end of the day, I want to get the maximum profit. Yes, this 3 is more than 0. Now I won't be able to add this item until the weight of my knapsack becomes 2. So this value for one knapsack size will again remain 0. Now moving forward, when my knapsack size becomes 3, what's going to happen? If my knapsack size becomes 3 and my item 2 has a weight of 2, that means if I add this item, I still have a remaining weight of 1 in my knapsack. Now adding this 2 will give me a value 3 plus whatever value I can get for 1. Now in order to check what maximum value I can get from this one can be checked in my previous row. Now in previous row, what is the value I can get for this one? So for one knapsack size, in previous row, I can get 0. So this will give me a value of total 3 if I add 2 for knapsack size 3. But I saw that if I add item 3 in my previous row, this is more value than 3. So I'll keep this as 4 because I want maximum profit. So instead of updating this to 3 by adding this item 2, I'll keep it as 4 because I can get more profit if I add item 1, which is weight 3 from this. Now same for item 4, for knapsack size 4. For knapsack size 4, if the weight of the item is 2, that means I still have a remaining weight of 2. This will give me value 3 plus whatever I can get the value of remaining weight in previous row. Now remaining value of this weight in previous row is again 0. That means I can get a value of 3 if I add 2 for knapsack size 4. But I can see the previous value was more than 3. So this will remain as 4. And same for 5. Now when my knapsack size becomes 5, I will add item 2. If I add item 2, I have a value of 3. And the remaining weight if my knapsack is 3. Remaining weight of my knapsack 3 has a value of 4 in the previous row. That means if you add this 3 value from here 4, your combination gives you a value of 7. Now this value is more than your previous row value 4. So you'll update this to 7. For knapsack size 6, when your knapsack size becomes 6, if you decide on adding this item that weighs 2, my remaining weight is 4. Now adding this 2 will give me a value of 3. But with this remaining 4, I can check in the previous row how much value of this 4 kgs I can get. So value for 4 you can again get is 4. So this will again give you a combination of value 7, which is again more than the one which was in previous row 4. Now for knapsack size 7, 7 minus 2 is 5. If I add 2 for this 7 size, I'll get a value of 3 plus whatever is the value of 5 in the previous row. So value of 5 in the previous row is 4. Again, this gives me 7. Now for 8. If I add this item to knapsack size 8, I still have remaining 6 kgs. Now this 2 will give me a value of 3 plus I can get a value of 6 from the previous row, which was 4. So this again gives me 7. Now coming to item 3. Item 3 has a weight of 4. That means I can't add this item until the knapsack weight becomes 4. So once my knapsack's weight becomes 4, I can get a value of 5. So for 4, the previous value that I'm getting is 4. Now 5 is more than this 4, so I'll update this. Now what about the values before it? I'll just copy it from the above row because I'm supposing these are the maximum ones. And I can't add this item until my knapsack size becomes 4. So for every row that you consider, you are only supposed to consider this item. You are not supposed to consider the rest of the items. I'm only concerned about this item. So moving to 5, when my knapsack size becomes 5 and I decide to add this item. So 5 minus 4 gives me a remaining weight of 1 kg in my knapsack. Now adding this 5 will give me, adding this item 4 will give me a value of 5 plus whatever is the value I can get from 1. Now what value I can get from 1 in the previous row? It's 0. So the maximum value that I can get here is 5. But in my previous cell, the value is 7. Now this will remain 7 because I want the maximum profit. Moving to 6. If I add 4 kgs to 6 size of my knapsack, the remaining weight is 2. Now this 4 will give me a value of 5. What about the value of 2? I can check in the previous row. The value of 2 is 3 in the previous row. So summing this up gives me 8. Now this 8 is more than my previous value 7. So I'll just update it. Moving to 7. 7 minus 4 again gives me 3. Now adding this 4 will give me a value of 5 plus whatever is the value of 3 in previous row. Now value of 3 in previous row is 4, which gives me a total value of 9. Now 9 is more than the previous value, so I'll update this to 9. Then for knapsack size 8, 8 minus 4, again I get remaining 4 kgs. For this 4, I'll get a value of 5. What about this 4? I'll check in the previous row. In the previous row, I can get a value of 4, which means this gives me a summed value of 9. And since it is more than 7, I'll just update this. Now moving forward to the last row. That is my last item 4. Now considering this item. For this item, I can only add this item when my weight of the knapsack becomes 5. Once the weight of my knapsack becomes 5, I can get a value of 8. So I'll update this to 8 since 8 is more than my previous value, which was 7. And for the remaining cells, I'll just copy the previous values because I can't add this item until my knapsack size becomes 5. Once my knapsack size becomes 5, I can keep on adding this item. Now, once my knapsack size becomes 6, what's going to happen? 6 minus 5, remaining 1 kgs in my knapsack. For this 5, I can get a maximum value of 8. But for this one, I need to check the previous row. This previous row gives me a value of 0. That means I end up with a value of 8. Now, the previous value in the row is also 8, and I'm getting 8. So this will remain 8 only. Moving to 7, when my knapsack size becomes 7, 7 minus 5 gives remaining value of 2. For this 5, I can get a value of 8 plus what value I can get for this 2, I need to check in the previous row. In the previous row, it will show me that I can get a value of 3. So summing this up gives me a value of 11, which is more than the previous value, which that was 9. So I'll update this. Now, for the last cell, when my knapsack size becomes 8 and I add the item that weighs 5, for this 5, I can get a value of 8. But what value I can get from 3? I need to check the last row. I can get a value of 4, which gives me a total value of 12. Now, this 12 is the maximum value I can get from these combination of items. Now, coming to next question. What combination actually resulted in this 12? How will you check that? So the first thing, wherever you see the largest number or the maximum profit, see which item corresponding to it. So I only got this value when I started counting this item. That was item 4. So item 4 is essential in my contribution for this value 12. Now, what's the value corresponding to item 4? It's 8. Now 12 minus 8, remaining value is 4. Now check where did you first see value 4. So if I look at my chart, I can see item 1 was the one that contributed to 4 first. So item 4 plus item 1 collectively will give me the maximum profit for my 0-1 knapsack problem. And that is how you solve it. Now looking at the code. The code is not that complex since the first thing you'll initialize your matrix. This matrix is of size n cross w, where n is your number of items and w is the maximum knapsack weight. And you keep on filling these for your different knapsack sizes. Then you will start iterating for your items, like filling these items, and there will be another for loop that will be filling for this to your maximum weight. Now max value without current. Now max value without current, this refers to my I minus 1 row. That what would be the I minus 1 value? So when I'm updating this value, I'm comparing it with my I minus 1. That if I don't add this item, how much maximum value I can get. So this statement represents my I minus 1 row. Now maximum value with current. So this is like initializing your maximum value with current because you will be updating it once you add the item. Now weight of your current is, again, current value can be seen from your minus. Current can be found from your item minus 1 array, that is this thing. For this block, you are essentially updating these values. So for example, when for item 4, my knapsack weight is 5. So once my knapsack weight becomes 5, that means I can get a value of 8. Now in order to fill these, this block of code helps. How? You'll find the maximum every time. Now maximum value current, this is the maximum value. That means the 8 value that you can get. Then how much is the remaining capacity? That is what I did here. Remaining capacity is 3. Now how much was the remaining capacity value? That means item minus 1. Now in order to check the value of 3, I checked it in matrix of item minus 1. And in this, I found the total maximum value. And every time after checking this, I compare it with which one was maximum, with current or max current. So with current and max current, with and without current. Which one is? Ultimately, you return whatever is the largest value, which can be determined by n, w. That's it. Thank you.